Hello, so this is just a very quick video about this massive equation that you see on the screen here. And I don't have too much content on this channel yet. I've recently made 3 very long math videos, one about the Riemann hypothesis and another 2-part one about prime numbers. And they're basically just an hour of me talking over some formulas about those topics. However, I thought I wanted to make a quick short video, something just to throw a little contrast on the channel. And I thought a good topic would be this one equation here. So this is a very unique and interesting equation that you probably can't find anywhere else. And what does it do? And what is it all about? So this actually comes from, this is an original version of something that I had an adapted version that I talked about in the prime numbers paper or video. So there was 2 videos I just threw up that are part 1 and part 2 of a just long discussion of me talking about prime numbers and prime functions and how you use periodic functions to analyze the prime numbers. But in that process, I developed this formula here, and this is a very unique thing that it does. And so I thought I'd make a quick video about it just because it's an interesting formula. So there's a method that's used to make this formula. And if you do find it interesting, you can look in the prime numbers videos that I put up. There are other versions of this that end up being more or less complicated. There are some that are simpler. But once you learn the technique of what's going on here, you could reproduce this in different fashions. However, for the sake of this video, I'm just going to talk about this one. And what you're looking at is what you'll see on the top of the screen here. I call it an even gap prime finder. And what does that mean? So you're looking at something that plots all the prime numbers basically, but more specifically primes with a certain gap. And the most famous prime gap discussion happens to do with the twin primes. So we have the famous unsolved conjecture of, are there infinitely many twin prime numbers, which are prime numbers that are 2 apart from each other. And because of the nature of the prime numbers, with the number 2 being the only even prime, it turns out that all prime gaps are even, meaning most primes are all odd numbers, and the difference between any 2 primes is going to be an even number, unless you're taking some prime minus the number 2. So this technically works, this formula, what I'm going to describe here, works for any size gap. It could be anything with the number 2, but then you're only going to get one result. So it doesn't really make sense. However, when you look at all the even gaps, you can have arguably infinite many results. And for the twin primes, the gap is 2, primes that are 2 away. And so I'm going to keep this video short and just describe how this thing works and pretty much leave it at that. If you want the details, you'll have to go to the prime video or write some comments or get a hold of the paper that this comes from, which is a paper I wrote. But what you'll notice if you look at this function is it's basically 2 product functions that are multiplied by each other. So yes, this is in parentheses here, and the fact that it's right next to this other one here, the back end, does imply, or it's meant to mean, that they are multiplied by each other. So the overall function is this first half times this second half. And you'll notice that these 2 are almost identical, these 2 halves. This part here, this cosine of 2x minus cosine 1 stuff, that's the same as it is over here. The only difference is in this first product function, you have this part in the back, where in the second one, you have the same thing, but you'll notice in the argument it's x plus n and x plus n versus just x and versus just x. Otherwise, these 2 things are identical. And technically, see, this is just how I wrote it the first time I had graphed this thing out and was building it. Technically, because these are 2 product functions multiplied by each other, you could just multiply these 2 terms by these 2 terms and put it all in one big product function. That's allowed too. So either way, you want to think about it. But if you plot this thing, for x is the variable that you're plotting, and the only other variable in here you notice is this n back here, this n. Well, that n over here, this represents the gap that you're talking about. So for the twin primes, you're going to set n here equal to 2. So plug 2 in for n and plot this. And what you'll see is that it plots all primes of that gap where all the values on the graph are 0, except those primes take a value of 1. And you'll see that this is a periodic function, or it looks periodic, it's quasi-periodic, and that you'll see the peaks, the wave peaks, represent the prime numbers of that gap. So for the case when the primes, you're looking at the twin primes, and this n is 2, if you were to plug in 2 to this and plot it, what it plots is the first prime of the pair. So if you plug in 2, you'll see all the first primes of the pairs. So the first twin pair is 3 and 5, so you'll see 3 is plotted. And then the next pair is 5 and 7, so you'll see 5 is plotted. The next pair after that is 11 and 13, so you'll see 11 is plotted. And this will plot all the twins, showing you the first twin of the pair. If you change the n to 4 or 6 or some other number, you'll see those primes of those differences. And the first prime of that pair will be plotted. But for the twin primes, put in 2 for n, and then you too can plot all the prime numbers of that form. So you can look visually and plot all the twin primes. This will plot all the pairs of whatever gap size you pick. All of them and without exception. Obviously you could extend the graph out to infinity or whatever, but it doesn't skip any, and it only plots the pairs and no other like erroneous data. So I'll leave it at that mostly. I don't think there's too much else I can say. It's just a big formula you have to plug in. If you want the paper, you can follow the other links on the channel, and there are other versions of this. The one I talk about in the Prime video is almost identical to this. It does the same thing, but I just thought I would leave this up there because it's a quite interesting formula. And it's big and clunky, of course, but it's neat. There's not too many things that just plot all the primes or plot all the twin primes or whatever. And so this is a unique formula. And again, there are infinite versions of this, all with different arguments in here for this cosine stuff. You can watch the other longer video to see, but I want to leave this short and just say, if you carefully put this into like Desmos or Plotter that can handle it, you will see that it plots all the twin primes when n is 2, or all the other gaps of primes when you set n equal to the gap that you want. I think that's about it. So if you have any comments or questions, feel free to leave them, and we'll keep this one nice and short. I hope you enjoy an even gap, or again, any gap prime finder plotting equation for your enjoyment. Okay, thanks everybody. Have a great one. Bye.